Hi students, this is VLSI Design. Today we are going to discuss about FPGA architecture presented by R. Subhashramani Devi. After completion of FPGA architecture, students can be able to what is an interconnect defined manufacturing lead time. FPGA architecture, first we are going to see the architecture. In the designer's choice, digital designer has various options. Already we saw that in number of integrator levels in the VLSI design. In the first class we are almost see that one. Here we are using the small scale integration circuits and medium scale integration circuits component. It's depend upon our designer's choice only. Difficulties arises as design choose size increases. Interconnections grow with complexity, resulting in a prolonged testing phase. In the simple programmable logic devices, PALs and PLAs, we are using PALs means programmable array logic and PLAs means programmable logic array we are using in the programmable logic devices. In the architecture not scalable one, it's a power consumption and delays play an important role in extending the architecture to complex designs. Implementation of larger designs leads to same difficulty as that of discrete components. After that, in the designer's choice, we are going to first of all choose the MPGA or FPGA. In the MPGA means masked programmable logic device. It has some features that are customized during fabrication, low volume expensive, prolonged time to market and high financial risk in FPGA. After that we are going to see the FPGA. FPGA means field programmable logic device. In this device have some features that is different from FPGA. These are all customized by end user, implements multi-level logic functions, fast time to market and low risk. It is are the two different high capacity in the designer's choice available in two choices, that's are MPGA and FPGA. After that, what is meant by FPGA? Two-dimensional array of customizable logic block placed in an interconnect array. Then like PLDs programmable at user's side, like FPGAs implements thousands of gates of logic in a single device, employs logic and interconnect structure capable of implementing multi-level logic, scalable in proportion with logic, removing many of the size limitations of PLD derived two-level architecture. FPGAs offer the benefit of both FPGAs and PLDs. Based on the principle of functioning completeness, FPGA means functionally complete elements, logic blocks placed in an interconnect framework. Interconnection frameworks comprises of wire segments and switches, provide a means to interconnect logic blocks. Circuits are partitioned to logic block size, mapped and routed. The basic building blocks of FPGA architecture. First of all, we are having max. We need to one using here, and then the max is connected to D flip flop. We are using here D flip flop, and then that the flip-flop and then programmable memory elements and one more mux is connected in the output session. These are all in the sequential output of the basic building blocks FPGA, and then show the shortened image of the building blocks. Here we are using the mini to one, that's why we are using mux. Then interconnection framework. Here we are using the each and every blocks connected with the connecting wires. Segregate with the blocks also. FPGA fine grained variable length interconnect segments. Timing in general is not predictable. Timing extracted after placement and boot. Then CPLD. Here CPLD means coarse grained SPLD like blocks. Programmable crossbar interconnect structure is also shown here, and then interconnect structure uses continuous metal lines. The switch matrix may or may not be fully popular. Architecture does not scale well. Here we are having the single SPLD connections and combined together and make the CPLD structure that are shown in the here. Faith programmability is achieved through switches, transistors controlled by memory elements or fuses. Switches control the following aspects: interconnection among wire segments, configuration of logic blocks. Distributed memory elements controlling the switches and configuration of logic blocks are together called configuration memory. This question of on FPGA architecture is list the advantages of CV. Thank you, students.